Hello guys, today let us discuss about very interesting concept of carbon steels. So straight into topic. So here we are having carbon steels, 5 carbon steels. Let us say A, B, C, D, E. And these steels are having hardness like this 15, 30, 45, 55, 65. So if we see all these steels, the hardness is getting increased. So how this hardness is getting increased for all these carbon steels? So if we say the composition, one of the feature is the composition. So if composition differs, hardness may differ, but here the composition, the weight percent of carbon for all these steels is same, 0.8%. so, so what other characteristic is making these steels having different hardness? So that is the microstructure. Because of different microstructures, these carbon steels are having different hardness. So for, let us say this coarse perlite, this is one of the microstructure. The B is fine perlite and C is bainite. D is called tempered martensite and E is called martensite. So these steels are having different microstructures and they are called these 5. So how they are getting these different microstructures? Because of heat treatment. So later let us discuss about this heat treatment. Here these are called, heat treatments are called annealing for coarse perlite, and fine perlite is called normalizing. For bainite it is called ash tempering. For tempered martensite it is called tempering, and for martensite it is called quenching. So whenever we are having same composition, so these carbon steels are called eutectoid carbons. Sorry, eutectoid carbon steels or eutectoid steels. These carbon steels are produced by reaction called eutectoid reaction. So what is this reaction? Eutectoid reaction is a reaction in which upon cooling one solid phase transforms isothermally and reversibly into 2 new solid phases. So solid upon cooling transforms into solid A and solid B. So these 5 carbon steels are also produced by this reaction in this process. So what is this heat treatment? So heating a material to a temperature, holding it for some time and then cooling. This is called heat treatment. So let us define it. Heat treatment. Heating a material to a temperature, holding it at that temperature for a period of time, followed by cooling at a specified rate, is called heat treatment. So if we try to put all these 5 heat treatments in a TTT diagram, we will get this. So the y-axis will be the temperature, the x-axis will be the time. So let us heat the steel to a temperature and hold. So the heating, holding. So for all the heat treatments, the heating and holding will be the same. What differs is the cooling rate. So first heat treatment process is annealing. Cool the material very slowly, means slow cooling. Then coarse pellet is formed. So if we cool somewhat faster than the first one, that is called normalizing. And here we can get fine pellet. So if we cool somewhat faster and then hold it for some time, and again if we cool, then it is called as tempering. You can say it is interrupted quenching. Interrupted quench. So here we can get bainite. And if we cool very fast, then it is called quenching, means so rapidly, so fast, very fast cooling. We can get here martensite and the 4. So after quenching, if we heat for somewhat more temperature and then hold there and then cool it, then we can get, so then it is called, that heat treatment is called tempering. So fast cooling, and we can get tempered martensite. So this is the phase diagram of a carbon steels. So this is the alpha phase, which is called ferrite. This is the gamma phase, which is called austenite, and this is alpha plus gamma phase, gamma plus Fe3C phase. Fe3C is nothing but cementite, and this is the alpha plus Fe3C, and this alpha plus Fe3C is called perlite. So if we see the reaction, so gamma, that is austenite, when austenite is cooled at a temperature of 725 degrees Celsius, so we get alpha plus Fe3C. The combination of these two is called perlite, that is combination of ferrite and cementite. So if we see in phase diagram, we can only see perlite. We can't say bainite, tempered martensite and martensite. This is because the phase diagram is at equilibrium position. So at equilibrium we can only get perlite. We can't get bainite and other 3 structures, other 3 steels. So phase diagram doesn't show all the eutectoid steels, but the TTT diagram, in TTT diagram we can see all the 5 structures of carbon steels. So let us see the structures of all these 5 carbon steels individually. So first of all, structure of pellet. So structure of pellet is nothing but alternate lamella of alpha and Fe3C. Lamina is means plates. So if we see the structure, these are the plates of alpha and FHPC. So whenever the distance between these two plates, generally it is called spacing. So whenever the spacing is more, then it is called closed perlite, and whenever the spacing is very less, means the plates are at a closer distance, then there is a form structure called fine perlite. So it depends on the spacing. So for slow cooling we get coarse perlite, and for faster cooling we get fine perlite. And then structure of bayonet. Structure of bayonet is nothing but fine needles. It's like fine needles. So tempering is heating a quenched steel below the eutectoid temperature. So if we see in TTT diagram, tempering, this is temperature and this is time. So at first we heat, so this is a eutectoid temperature. So at first we heat the steel, heat the material, and then hold it for some time, and we quench, we cool it very fast. So that is quenching. This is heating, holding, and quenching. So here we produce martensite, and again cooling it for a temperature below the eutectoid temperature, and then holding again for some time, and then cooling gives us tempered martensite. This is tempered. So if we see equation, martensite when we quench gives martensite. So when we temper this, we get alpha plus FeC, which is tempered martensite. So here the FeC will be in the form of fine particles. So here the martensite is very hard and brittle. So what is the need to change martensite into tempered martensite? Why we are doing this process tempering? So difference is, here martensite it is very hard and brittle. So if we want somewhat lower hardness, and if we want to change this brittle, so we do tempering, and we form tempered martensite. Here it will be somewhat lower, but it is sufficient, lower hardness, better toughness, and ductility. So these are the different structures, different microstructures of carbon steel. That's it.